Okay, I wanted to look at this example here. It is actually something we could have done previously with optimization problems and derivatives, but many word problems, there's more than one approach. This one, however, because of the way it's worded, they're telling you the variable here, the discount x. I know we haven't really read through it, but just kind of as a intro to this problem, that's what could really mess you up. The problem isn't half bad, but you have to be careful of the details here. Okay, so let's read through it really quick. Shakespeare's Pizza sells 1,000 large veggie pizzas per week for $18 a pizza. When they offer a $5 discount, the weekly sales increase to $1,500. So notice we don't have any cost here. All we're talking about is revenue. I'm selling pizzas. If I offer a discount, how many do I sell? Nothing about wages or the building costs or anything like that, because at some point we can't offer too large of a discount. We wouldn't make any money, right? I mean, if they were $18 and you offered $17 discount, even though I prefer meat on my pizza, I mean, for $1, I'd buy pizza, often. I can't say every night, 'cause, gotta live, I can't die of obesity or anything. But anyways, moving on. Part A, assume a linear relation between the weekly sales A of X and the discount X. So first off, let's break that down. What is it saying? So first off, linear, okay? What does that mean? So the discount is X, right? X is our discount. And A of X is the sales. A of X is the number of sales, right? How much pizza do we sell? Well, the more the discount, a function could increase exponentially, right? If I offer $0 discount, I'd still sell pizza, but the higher the discount, the more I'd sell. But this case, it's saying it's linear, so we know it's doing that. Now, why is it doing that? Because we could look at it, right? I sold 1,000 to start, no discount, but when I offered a $5 discount, okay, it went up to 1,500. So that point is 1,500. Whoop, not 15,000, 1,500. Okay. So not the price of the pizza, but the discount. So it wants a linear relation. Find A of X. So find, right, A of X is Y. So really it's saying find Y equals mx plus b. So m, the slope, we could do y2 minus y1. I have 1,500 minus y1 is 1,000, right? It's the y-intercept, over 5 minus 0, right? X2 minus x1. So 500 over 5. So that's 1,000. And I'm going to put this 1,000 over 1 only to make sense of this. What does that mean? That means we're increasing, we're selling 1,000 more pizzas, right, per is division, every $1 discount. Sometimes making sense of the problem, and a graph wasn't required, I can't really just jump to a solution right away, right? Sometimes I gotta write this out. Now in this case, because I drew this graph, I already know b, but we could always solve, substitute x and y and plug it back in there and find b. But b is the initial value, right? The initial y value. Initially, no discount, I sold 1,000 large pizzas. So we know b is 1,000. So therefore, A of X, let's change the color so it sticks out. A of X equals 1,000 X you know what? I knew something didn't look right. 5 1500 minus 1000 is 500. Duh. So 100 pizzas for every $1 discount. I'm looking at this, I'm like, wait, 1,000, right? We started at 1,000. We started at 1,000 and it increased to 1,500. So going up 1,000 pizzas, that didn't even make sense. Alrighty. So 100 x plus 1,000. Alrighty, that looks good. Part B. Find the value of x that maximizes the weekly revenue. Revenue equals A of x times the price. Okay, this part's a little tricky. So this is what we're trying to maximize, right? The money we bring in, or revenue. A of x, remember x times p. Well, A of x is the number of cells, right? So this first x here is a function in itself. So I need to put A of x there. So A of x times the price. So A of x is 100x plus 1,000. The price, well, the original, this part's weird too. The original price was $18, but we're taking off a discount. The thing is, I don't know what the discount is, right? The price, if it were a $5 discount, the price would be 13. So 18 minus 5 is 13, but say the max value is like $2 discount, then this would have to be 16, and that's why it's 18 minus x. All right, now we're trying to maximize this. We can distribute everything out, right? You can FOIL it all out. Or just use product rule, call this f and call this g, and when we do derivative, f prime g, so the derivative of f is just 100 times 18 minus x, plus f 100x plus 1,000 times the derivative of g, which is a -1, right? Derivative 18 is 0, derivative negative x, -1. Okay. So now we set the derivative equal to 0. I think we're going to have to distribute now. So 1800 minus 100x minus 100x minus 1,000. So combine these and we'll bring it to the other side. That'd be -200, so add it. 200x equals 1,800 minus 1,000 is 800. X is 4. Remember, x stands for the discount, so $4 discount. Let's make sure this in fact is a max. So let's check that it's a max. If this was first derivative here, which simplified to this here, then that would be 800, right? R prime is 800 minus 200x. So second derivative is just -200. That tells me it's concave down, which in fact tells me it's a max, so we are good. Okay, part B, find the value of x. $4 discount is x. C, answer parts A and B if the price of one pizza is $9 and all other data are unchanged. Okay. Well, looking at this then, the original was $18 a piece. I'm kind of glancing through like, all right, I didn't use that anywhere in A. I didn't use the fact that $18 pizza. I didn't use it till right here in B, right there. So therefore, everything should remain the same, except change it to a 9. Okay. So now when we do derivative, we're going to get what the same thing except for 100 9 minus x plus the rest will be the same. Okay, now when we distribute here, we'd have 900 minus 100x minus 100x minus 1000, setting that equal to 0. So again, we'd get 200x on the left, but now 900 minus 1000 is negative 100. So x would be negative 100 over 200, negative 1/2. So the discount is negative. So that means they actually add the price, right? They add half of $1. So that doesn't make sense, right? That $9 were already too low. We passed that max.